Taking a look at graphing quadratic functions in standard form. So chapter 4 here is probably your first experience working with quadratic functions and graphing parabolas, which is these graphs below, the graph of a quadratic. So we're going to start by looking at a quadratic in standard form, which is your y equals a x squared plus bx plus c, where the coefficients a, b, and your constant c all play a pivotal role in giving you information about your quadratic and your graph of your parabola. So here you can see our first graph on the left here is when a is greater than 0. So when you have a positive a value, your parabola or graph of the quadratic will look something like this. Where if you have a negative a value, when a is less than 0, your quadratic graph will look something like this. So that leads us to the characteristics of your graph. So first thing here, when a is greater than 0, your graph is going to open up. Well, when a is less than 0, your graph will open down or reflect over the x-axis. Okay, this is what we saw in the examples above. So that leading coefficient on your quadratic in standard form determines which way your graph opens. So kind of a similar concept to your absolute value graphs. When the absolute value of a is greater than 1, your graph is narrower. Well, when the absolute value of a is less than 1, your graph will be wider. So this is like if we would have a fraction or a decimal. Well, in this case, you will have a number greater than 1. I think of this as slope. This would be if you have a higher slope, you have a more narrow graph, and while you have a lower slope, your graph opens wider. Okay? If your a value is greater than 0, so if you have a positive a value, your vertex will be the minimum value. Well, if you have a negative a value, your vertex now becomes the maximum value. We can see that in the graph above. Okay? Right here, our vertex is our minimum value, and then in our other case, our vertex is our maximum value. Our x-intercepts are just the real zeros of your graph. Okay? You can have anywhere from 0 x-intercepts to 1 x-intercept all the way to 2 x-intercepts for a quadratic graph. And your y-intercept is just 0, c. So your c value, your constant on the end of your quadratic, is actually just your y-intercept. So we can also find zeros of quadratics. I'm not sure necessarily which order we'll be teaching these in, yet all of these following skills are valid ways to find the zeros of a quadratic. So the first way, and probably all of your favorites, will be factoring. Okay, you can also solve by using square roots, completing the square, or the quadratic formula. Many of you have probably already heard the quadratic formula before, but if not, it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where you just substitute the values from each of your coefficients into the formula and solve. The quadratic formula is a very effective way of solving for your zeros in a quadratic, yet with the amount of computation, it isn't necessarily the most efficient all of the time, yet it is very reliable. So the axis of symmetry, which can be seen on the graphs above, is the line that, as the name says, splits your quadratic in half, or it is symmetric on both sides. So to find the axis of symmetry, we can use the formula x equals negative b over 2a. Okay? As you can see, x equals tells us that we are having our vertical line, which is true of the axis of symmetry, but we can also use this formula to help us find our vertex. Our vertex is negative b over 2a, becomes our x value, as stated above. But then, to find your y value, we can plug in our x value into the quadratic and solve for y. Okay? So we can take this value that you find with your axis of symmetry formula, plug that into your equation, and solve for y. It's the same concept as our inputs and outputs. Okay? So I know this is a lot of information about your graphs of a quadratic equation, yet let's take a look at one example of applying all of this information to investigate a quadratic function in standard form. So on the second page here, we are given a quadratic in standard form. Okay, there are a lot of different things we need to do to solve for this, yet I think a good starting spot would be the first blank they give us, the AOS, which is just short for axis of symmetry. So if we are finding the axis of symmetry, we need to use the formula A equals negative B over 2A. So we have x equals, I might have said A equals, I meant x equals, negative B, which is just negative 4 over 2a. So 2 times 1. I should go back up to our quadratic here. Remember, a is the coefficient on x squared, which in this case is just 1. B is the coefficient on x, which is negative 4. And c is our constant. Okay, going back to our equation here, negative b over 2a. Let's go ahead and solve. This becomes 4 over 2, which is just 2. So our axis of symmetry is x equals 2. Oh, sorry about that. So, like we talked about, the next blank here is vertex. The axis of symmetry allows us to find the vertex by plugging in our x coordinate into our quadratic to solve for y. So let's plug in 2 to solve for y. So we have y equals 2 squared minus 4 times 2 plus 7. Let's go ahead and simplify. 2 squared gives us 4. Negative 4 times 2 gives us negative 8 plus 7. We can simplify this as y equals 3. So when x is 2, y is 3. That right there is our vertex. All right, so I think at this point, let's go ahead and start taking a look at our table and graph here. So our vertex, it's great that we started by finding our vertex because that gives us kind of a starting point for our table. You know that when we input 2, we get 3 as our y value. So we'll use that as our starting point because that is our vertex. Okay, so let's trace back from this. We could input 1, we could input 0, or we could input 3 and 4. So let's start working our way back. So if we're starting at the top here, this gives us to our next blank as well. When x is 0, right, we are working right here on the y-axis, that becomes our y-intercept. Remember, your y-intercept is just your c value. So in our y-intercept blank, we have 0 as our x value and 7 as our y value, y-intercept. It's right there, 0, 7. If we were to substitute in a 1, we'd have 1 squared minus 4, which is negative 3, plus 7, which gives us positive 4. 3 gives us 3 squared, which is 9, minus 12, plus 7, which gives us a positive 4. And then when we input 4, we would get 16 minus 16, which is 0, plus 7, which just gives us 7. Make sure when creating your own table that you're taking your time so that you're accurate, so that when you graph, you have the correct graph. So from here, we have filled out our table, so we might as well graph at this point. So let's start with our vertex. 2 on the x-axis, 3 on the y, 1 and 4, 3 and 4, 4 and 7, 0 and 7, and right there, we have made our quadratic. As you can tell, the quadratic has a similar shape to our absolute value equations, yet more rounded and definitely different. All right, let's keep going through our blanks now. So we have a max or minimum value. So in this case, our a value, which is 1, is positive. So that means that we are going to have a minimum value. So when they ask for this value, it's essentially asking what is the y value in your vertex, which in this case would be 3. That is the minimum value that you can get as an output for this quadratic. Okay, the next section, zeros. This is probably the most difficult section for, investigating quadratics as a whole. We have zeros. Okay, so first of all, we can try to factor this. 0 equals x squared minus 4x plus 7. But if you try to factor this, you're going to realize that this is not factorable. Okay, so that leads us to go down the list and try a different method. So I think for this, completing the square would be an effective method for solving. So to complete the square, you have to start by subtracting your c value to the other side. So that leaves us with x squared minus 4x, we'll leave a blank here, equals negative 7. So in that blank, we are going to take our b value, divide it by 2, and then square it. So we would take negative 4 divided by 2 squared. That's going to go on both sides of your equation so that nothing changes. Negative 4 divided by 2 gives us 2. Squared gives us positive 4. Okay, let's go ahead. Right here, we have difference of squares. Gives us x minus 2 squared equals negative 3. Let's go ahead and try to solve for x. So we can take the square root of both sides. That'll leave us with x minus 2 equals the square root of negative 3, which becomes an imaginary number. Remember, whenever you take the square root, you have plus or minus. Then let's add 2 to both sides. That leaves us with x equals 2 plus or minus I square root of 3. Okay, I'm not quite sure the order that we go through the lessons, yet I hope that we learned some of our factoring skills prior to this lesson so that this makes a little bit more sense. Anyways, our zeros is x equals 2 plus or minus I square root of 3. Okay, the reason that we have an imaginary solution for zeros is because our parabola is above the x-axis. So our zeros, in this case, would be imaginary. Our x-intercepts, we will never cross the x-axis. So our x-intercepts would be none. Then your guys' favorites, domain and range. As you can tell with this graph, if we're looking at domains or x values, we continue both the positive and negative direction forever. Although we are becoming more vertical, it still slightly heads more negative and slightly heads more positive forever. So our domain, you could write this as all real numbers, or in interval notation, negative infinity to infinity. Our range is slightly different. We have a minimum value of 3. So we start at 3 and we go up forever. So in interval notation, this would be square bracket 3, since we have a point there, to positive infinity. You could also write this as an inequality, y is greater than or equal to 3. Okay, depending on your personal preference there. So I know this lesson has a lot of new information and a lot of new concepts. Okay, give the second example a try on your own. Give this a try. Okay, we're going to come into class and we'll start with this example. Make sure to ask questions if any of the pieces of information that we are investigating doesn't make sense, and we'll try to clear things up. Thanks for watching.